Good morning. I don't know if my brothers watch this at all. They say, really? You're on YouTube? They find it kind of interesting because I'm fascinated that anybody would watch me. It's kind of like you have to. So it was Bill and Bruce's birthday yesterday. They turned 39. Not 39, excuse me, 59. 39. That was a long time ago, 59. I'd show you a picture of them. Have I ever shown you a picture of them? Let's see if I can find it on this machine. Why is my phone in Spanish? Is that supposed to happen? Here's my brothers. Right there. They look just like me. Can you see that they're twins? Do they look alike? A little bit. That's Bruce, that's Bill. Bruce is the youngest by 2 minutes. So, we had many adventures together. Let's see, oh, all these, I thought there was another thing on here. Let's see, there's one, there's a cute one. I'll show you a cute one. I'm kind of bragging right now, but what the heck. I broke Bill's leg when he was younger. Hooray? Why would you say hooray to that? I can't find it. Maybe it's this one. I guess I can't find it. Maybe I'll find it later. All right, back to this. The reason I bring this up is we did stuff to each other all the time and revenge type of things. And so this might have been a revenge of when I broke Bill's leg. So here I am. Here's the garage. Here's the ground. It's a 90-degree angle. And right here's the ladder. And it's 20 feet. So the ladder's never changing. It's constant, Cora. It's not moving up and down, otherwise I can't paint. It would not be a good ladder if I stepped on it and went down. It'd even be a worse ladder if it just jumped up. Okay. And Bill's here, and he yanks the bottom of the ladder. And I'm up here painting. And I fall straight down. And the paint spills. Some of it got on the garage, which we didn't care because we were painting the garage. The large majority of the paint fell on me, which was not good. Pardon? That's the end of my story. Not very exciting. Okay, so I'm going to call this distance x because it's changing, right? Because the ladder will eventually get like this, right? And then be flat. You got the idea? And this right here is y. And so y is the distance that it's off the ground. And like here it's high, here it's low, and here, you know, I'm almost in pain. I sprained both of my ankles when that happened. Okay. It's a painful moment. Okay. And so, give you back the initial one. And so when you do these problems, I would suggest to come up with a drawing. It doesn't have to be beautiful. Some people draw it better than others. I would make sure I'd label. And they will always have to give you a rate. And notice they give you a rate right here. And so I'm going to write 2 feet per second like we did on the front part. And you know that's a rate, so it's going to be something over dt. And there'll be a d up here. It's going to be what? It says this: if the lower end of the ladder is pulled away by your brother, that's the part that's missing, at a rate of 2 feet per second. I don't have an L. What is it? It's x. It's dx dt. Because I got an x here, right? That's where the bottom is. It's being pulled away. All right, so this is x. This is y. So now you have to think about this. And I thought about this yesterday when I was walking my dog at Quarry Park. You guys know where Quarry Park is? Okay. And so there was a brief moment that my wife wasn't talking. Oh, maybe she was talking to me. I just quit listening. And I started thinking about you guys and how I was going to teach related rates. And I'm going to think, okay, I drew this right triangle. What kind of formulas, Andy, come out of a right triangle? Pythagorean theorem. So what would be the Pythagorean theorem here, based on my beautiful drawing? Like that? And there's not, you could have written it as y squared plus x squared. Doesn't matter. I'm an alphabet person, so I go x squared. Math, you know. So that's perfectly fine. Okay? Would you agree? So in other words, the Pythagorean theorem is a formula that demonstrates the relationship of the sides of a right triangle. Would you agree? It demonstrates the relationship between these three sides. It's only true on a right triangle, correct? And I have a right triangle. All right, so once you get that, okay, you want to come up with that equation. And then what you're going to do is you're going to take the derivative of it, use an implicit. Now this is an implicit form, right, Morgan? Okay, because x and y are being used together. And we're going to take the derivative of this with respect to time. Nikita, let's see you take the derivative of this with respect to time.
So 2x dx over dt.
Perfect.
Plus 2y dy over dt.
Perfect.
And then equals 400. Oh, 0.
0. We get to annihilate that baby, right? Because it's a constant. So I could even go one step further, Nikita. Would you be okay with this? Just because it makes life a little bit less complicated. Well, I don't know if it makes life a little bit less complicated, but it surely makes that equation less complicated. Just divide everything by 2. Everybody okay with that? So I have 1, 2, 3, 4 variables, right? And they give me some information. First of all, Hunter said dx dt is 2 feet per second, correct? Oh, let's back up a little bit. I think it's always good to get some information. I'm trying to figure out, it says, how fast is the top of the ladder coming down? So what am I trying to find? Thank you. That's awesome. dy dt. Do I think dy dt will be positive or negative? Why? Because it's going down, right? Alrighty, so now I can plug stuff in. What in the heck is this 12? Well, it's not the initial height. It's going to be 12. I don't know where 12 feet is here, right? If I have this ladder smack dab right against there, which you cannot stand up. If you try, you fall backwards, just to let you know. But you know, I might be up 18 feet, 17 feet, right? It's just a particular moment in time that I'm 12 feet, correct? But it is what y is, correct? So y is equal to 12 feet momentarily. Does everybody understand that? It is not a constant. 20 is a constant. 12 is not a constant. And the reason I emphasize that is some people get confused. And notice I'm going to put 12 in here in a bit, but it's not going to go into my general equation because I got to take the derivative because all these variables, these 4 variables are changing, right? All right, so I know dx dt, that is 2. So I've got times 2. Do I know x? How did you get 10? Oh, you can. You didn't say 10. You can figure it out. Okay? How can you figure it out? So what do you want me to do here? Equals 400, right? Because we figured that was, somebody told us that in here. And so do you know what 12 squared is? Did you say 144? Sound like 143 to me, but okay. You wouldn't say 143, would you? Okay. So that gives me x squared is equal to what? 256. So that means x equals 16. Now it's equal to negative 16 too, but that's not a good choice, right? Because in our problem, you wouldn't have a negative 16 unless you're in a different parallel universe, right? Okay. All right, so now I can put in 16. So I got 16 here. That's x plus y. I know y. That's 12 times dy dt. That's what I'm trying to figure out, equals 0. So once you do the calculus on these problems, this is kind of a nice problem to do, right? Would you agree? So dy dt is equal to a negative 32 over 12, which is the same as a negative 8 over 3. Okay? What are my units? Maya, do you have an idea how fast it's dropping? It's dropping a negative 8/3 what? I'll give you a hint. It's got seconds on the bottom. What? Feet. Right? That is a particular length, which is feet. So its rate of change, Emma, is feet per second. Does that make sense to everybody? That is a very, very common problem you are guaranteed to see on Friday. Guaranteed. All right. Can I go to the next one, or did you have any questions about this? Are you kind of following my process? Next page. Now notice we only got 3 more to go, correct? That's good, isn't it? Now, you have a camera. It's mounted 300 feet from the Space Shuttle launching pad. So right here is the Space Shuttle launching pad. See how I spelled it? Okay. Over here, you have the camera. I suppose you could have went to the right, but I figured I'd go to the left. This distance is 3,000 feet. Is it constant? Yes. You have a space shuttle that's going vertical. Is it constant, Cora? No, because it's going up, isn't it? What letter do you want to use to represent that? S. I don't like S, but we'll use S. You know why I don't like S? It looks like a 5. Okay. Now, it says this. The camera needs to pivot as the shuttle is launched and needs to keep the shuttle in focus. If the shuttle is rising vertically at 800 feet per second. So I'm going to write 800 feet per second. That is a rate, correct? Something over time. What is it? It is the rate of what variable? Are we okay with that? Then it says, if the shuttle is rising vertically at 800 feet per second, when it is 400 feet high, what is 400 feet high going to be? S. Is it always at 400 feet? Just at an instant. Would everybody agree? Okay. How fast is the camera to shuttle distance? Well, here's the camera. Here's the shuttle. That must be that distance, correct? So at one time, that was my distance, correct? At another time, that was my distance, correct? So is this distance always changing? Yes, it is. What do you want to call that distance? No, Allie. P. Oops. So that's P, correct? Right? Now it says how fast is that distance changing? We're trying to figure out how fast what dp dt is. Would you agree with that? Notice, side, 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 correct? It's just like the ladder problem. Don't you think? Didn't the ladder problem, one of the sides was a constant and the other two were changing? So, Holland, you're nodding in agreement. That makes me feel good. What's my general equation? I got to create an equation that has, it's a right triangle, by the way, that relates all three sides. Tell me what it is. Okay, I don't have an eraser up here, so what do you want me to write? Did you say s squared? Oh. Then did you say plus? Okay. Did you say 3,000 squared? Okay, I didn't hear any of that. I heard the s squared and then I heard the 3,000 squared. Okay. Equals what? P squared. Okay. Ellie, will you take the derivative of this for me? What happened to the 3,000 squared? What's the derivative of that?
0.
Awesome. Why? Beautiful. Equals what?
2p
And I can get rid of the s. Would you agree? Yeah, the 2. Sorry. Thank you. I don't know. I slept 3 hours last night, so I think it's starting to catch up with me. I'm so worried about this class. Alrighty. All right. Do we know s? Do we know s for an instant? 400. Yes, we do. Thank you. 400. Do we know ds dt? What is that? 800. So you know how I come back here and say, all right, yeah, I wrote s down, I wrote ds dt down. You see what I'm saying? I go through the problem and I write them down right away. Equals. Do I know p? Can I figure out p? I know it's not 10 because I've been told that's wrong, right? Can I? So how am I going to figure that out? Tegan. Okay, I'm going to show you how I'm going to do that on my calculator, all right? I'm guessing these aren't perfect squares, right? I'm just throwing that out there. And so I got to have my answer accurately rounded to 3 decimal points. And so I'm going to show you how to do that. And it works the same way both on a TI and a Casio. So that's the first thing I do. And I get a humongous number. I know I'm going to take the square root of that to get P, correct? So I go shift, and you should have something that says shift answer. Does everybody know that? So every time you do a calculation, it stores it in an answer location. I do not round that number yet. I only round my answer. I'm going to use this number, okay? So do you see that I'm going to take and I'm going to divide 400 times 800 by P. Do you see that? Would everybody agree with that? So I'm going to write this, and I'm going to lie to the person that's correcting this, and I'm going to write this down. Now, I rounded it, didn't I? Correct? But I'm not going to use the actual rounding part. I'm going to take 800 times 400, and I'm going to divide by that answer. In other words, even this is incorrect because there are more decimals. It's just not displaying them all. Is everybody okay on that? And I'm going to press that answer, and that's what I'm going to round. You only want to round your answer to at least 3 decimal points. Now, could I write 105,730,9761 and be correct? Yes. Are there people that do that? Yes. I could write down 105.731, correct? Can I write 105.730? No. Everybody got that? So I'm going to write 105.731, and now what are my units? It's per second, correct? What is it? Feet. Okay. Now number 8 and 9 I screwed up. I would tell you that the volume of a cone is equal to 1/3 pi r squared h. Okay? That would be given to you on number 8 and 9. Are you okay with that? Some people memorize it. You don't have to. All right? So it says this: sand is poured on a beach, creating a cone whose radius is always equal to twice the height. So the radius equals twice the height. Did you do things in algebra, advanced algebra, when it gave you a sentence that you converted into algebra? Yeah. Okay, so this isn't foreign? Okay, I do that right away. Notice how I'm going through this and I write it down. And so what it looks like is a cone that looks like this. Here's my radius. Here's my height. And then it says this: sand is poured at a rate of 20 inches cubed per second. It is a rate. A rate of what? Zach, do you have an idea? A rate of what? I am sorry, Ryan. Ryan Zasky. Okay. Whose nickname I've created, which is incorrect. What is that a rate of? Okay, all right. Aaron, it's 20 inches cubed per second. It's a rate of what? Of volume. How do you know it's volume? Because inches cubed, correct? Cubic inches are a measurement of volume. If it was inches squared, it'd be a rate of what? Area, correct? Everybody got that? Alrighty. What else do I know? I know that right here, for a brief moment, h is equal to 6 inches. Right? Now, if I'm going to have to take the derivative of this, right? That's my general formula. I know, because I have r squared and h, that I'd have to do the product rule, correct? right? But it says right here, how fast is the height changing? So I'm trying to find dH dt. Notice how I write that down every time. Do I care about the radius? No. Can I get rid of the radius? I can replace the radius with what, Cameron? Well, no, I don't want to change it to f. I can give it a better name. I can even get a better name than that, because I want to figure out what the radius of the height is. 2h, because the radius and 2h are the same. Okay, so I'm going to rewrite this. I got volume equals 1/3 pi 2h squared times h. That gives me volume is equal to 4/3 pi h cubed. Where did the 4 come from? 2h times 2h is 4h squared. So I took 1/3 times 4, and then I took the h squared times the h and got h cubed. Why would I do that? What makes it so nice now? Why is this better than this? What don't I have to do now? I'm going to have to take the derivative, right? Correct? But I don't have to do what rule? Yeah, because r is gone. I just got to do the power rule. I like the power rule. I like the product rule too, but the power rule is my standby. It's like my favorite hammer in the garage. So I'm going to take the derivative. I got dv dt. 3 times 4/3 is 4 pi h squared times dh dt. Wasn't that a lot easier than the power rule? You could use the power rule. You'll eventually have to use that anyway, right? Now, I have 1, 2, 3 variables. I'm trying to find dH dt. What is dV dt? 20, correct? Equals 4 pi times 36. Do you see where I get 36? I see people nodding. Now, this is the way I divide. I take 20 and divide it by 4 right away. I get 5. And then I'm going to have 36 pi on the bottom. I do not have 5 pi over 36. That's different. And you can figure out what that is on a calculator. And there will be people in here that do that, but I don't care. Just make sure it's to at least to 3 decimal points. What's my unit of measurement? Say it again. So that's a change of volume. It's a change of height, correct? So at one time it's 6 inches, correct? Could it be 7 inches at another time? Could it be 8 inches at another time? So it's a change of inches, correct? It's not a change of cubic inches. So it's going to be inches per second. Are we okay with that? All right. Aaron, okay? Now, this is like number 21 on the homework on 2-6, okay? So if you're attempted to do 21, I'm going to make it easier for you. Because this always happens, and you'll want to take note of this, this always happens with cones. And they're always right cones. This is a right cone. Does everybody know what a difference between a right cone and an oblique cone? Right, you got a right triangle. Oblique cone means you have this triangle is off center. This apex is somewhere. It's a weird cone. We don't talk about weird cones. in AP Calculus AB. When you get to college, they'll talk about weird cones, okay? But right here, we're not going to talk about weird cones, okay? So we're going to talk about right cones. And so we have water is draining from a conical tank. So again, I would give you that the volume is equal to 1/3 pi r squared h. I would give you that. So here's my cone. It's leaking, so I got some drops there. It's got a radius. It tells you the radius is 4 when it's full, and it's 16 when it's full. Okay? And it tells you this. It's actually draining, isn't it? So it's a -2 meters cubed per minute. That again is something dt. What is it? Maddie Bittman. Okay, what's C? Okay, because you like C. I like C too, okay? And I'm not anti-C. I would never be anti-C. But I think sometimes there's better choices. What does meters cubed indicate? Volume. And I think in this case, having a V for volume might be a little bit clearer. I hate to tell you that I'm not going to choose C, but that's what I'm going to do. Okay. All right. And even I'm going to give you 2 more ones as an examples when I'm done with number 9, because there's some relationships you need to see. And one of them is going to be, I'm going to use volume on that also. Okay. Alrighty. And now this is, and then this is right, 2 meters high. For a moment, H is 2 meters. Now, eventually, this thing was full, but eventually it'll drain and only be this high, right? Correct? So what I can do is I can kind of take this and draw a triangle that looks like this. So here's 4, here is 16, and here is where it's that level. Does everybody understand what I mean by that? Can you see that okay? Does everybody understand what this line means? That's how full the cone is, okay? And it also will be a right triangle. This will be R, and this will be H. Now, I have a big right triangle and I have a little right triangle, correct? Both of them have 90 degrees. Both of them share this angle, correct? And since a triangle adds up to 180, and this one has to add up to 180, these 2 angle measurements have to be the same. Would you agree? So they are similar triangles. You will always get similar triangles on cones. Always, always, always. So what's special about similar triangles, Nick, is that they are proportional to each other. The sides are. So that means 4 to 16 is equal to the radius over the height of any place that it stops here. Now, could I have had 16 over 4? Yeah, but then I would have to have h over r. Does everybody understand that? And using algebra, I can say 4h equals 16r. Are you okay with that? You will always be able to do that. So now I come over here. How fast is the water level falling? What am I trying to figure out? D what? dH. Do I care at all about the radius? So I could say that 1/4 h is equal to r, correct? You know why I'm going to do that? Because I don't have to do the product rule then. I can get rid of r, can't I? So I can come back here and say V is equal to 1/3 pi 1/4 h squared times h. And v is going to equal, well, 1/4 times 1/4 is 1/16 times 1/3 is 1/48 pi h cubed. I like that because it's just the power rule, Josh, right? Okay, you caught up? Okay, what's the derivative of v? What? I'm going to get it in a second. I just rewrote the volume formula. You're faster than me and Josh. We're going to get dH dt right now if Josh does what I suspect he's going to do. Right, Josh? Okay, what's dV dt? Oh, excuse me. This is going to be dV dt, right? What is 3 times 1/48? Do you know? It's 3/48, right? Do you know what that simplifies to? 1/16. Very good. 1/16 pi h to what power? Second. Times dH dt. So now I'm going to plug in the numbers. I get -2 equals 1/16 pi. H is equal to 2, correct? And I'm going to square h. So it's going to become 4. Does everybody see where 4 came from? Yeah, I see nods, so I'm assuming that's okay. Times dH dt. Well, 1/16 times 4 is 1/4. So this means I'm going to multiply both sides by 4. This will be a -8 over pi dH dt. So all I need now is the units. Are you okay that I did that in my head, a -8 over pi? See how much easier that is, Allie? Okay. What are my units? How fast is the height dropping? Well, it's a -8 over pi meters per minute. Awesome. Very, very good. Did you guys harmonize that? Huh? Oh. Meters per 60 seconds. That's what you were going to say, right? You just forgot the seconds. Okay. This is like 100 centimeters per 60 seconds. Okay. All right. I'm going to give you 2 more. Is that okay? Tomorrow's going to be a complete work day, folks, and maybe some of today. Okay? I got a different tank. It's called a cylinder. Its volume is pi r squared h. And this distance, oh, let's make it 3 feet. And this distance, when it's full, is 5 feet. It's kind of like a barrel. And it also is leaking. It's leaking at a rate of 0.5 feet cubed per hour. Find dH dt. When h is 1 foot. Yes, sir.
Just out of curiosity, is it possible to use the position function?
Do the what?
Use the position function.
Position function means it's falling through the air, correct?
Yeah, but you'd have different numbers. But it's still maybe.
So you have gravity is causing why it's leaking, correct? So I would say yes, there's a function that has an issue with that could involve gravity. You have some type of friction because of what it's leaking through. Yeah, perhaps. But again, I did not take physics, so it's beyond my scope at this moment. Okay? Okay. Everybody okay with this? So, when it is this high, what's the radius? When it's this high, what's the radius? When it's this high, what's the radius? So the radius doesn't change, does it? So one of the things you need to do is always ask, what are your variables? So in this case, since it's draining out of a cylinder, the radius is always a constant. Would you agree with that? So that means this can become volume equals 9 pi h. Does everybody see where I got 9? From r squared, correct. Does everybody see why on a cone the radius is changing? Okay, so dv dt is equal to 9 pi dh dt. This is, oh, this should have been a negative, correct? So it's going to be a negative 1/2 equals 9 pi dh dt. So I'm going to get a negative 1 over 18 pi. Is equal to dh dt. What are my units? What? Feet per hour. Are we okay with that? How much time do I have? Oh. Easy peasy. Doing okay? You think we can do one more problem and then you got a work day tomorrow? Can you handle that? Okay. So we got this rocket. Remember this camera right here? And the Space Shuttle launching pad, correct? And this rocket's going up in the air, correct? Oh, who was this? Somebody called this a letter. S. Who was it that called it S? Yeah, S. And S for a moment was 400 feet, correct? Right? And ds dt was equal to 800 feet per second, correct? And this was a right angle because it's going up vertically. And this camera was looking at the different times that it was there. So I want to know the rate, the angle of elevation of the camera is changing. Oh, I don't think I want that. The rate of the angle of elevation of the camera, right there, question mark. Cross out changing. So right here, so you got this, right? The angle of elevation is this way, and then as I look up, this is theta, and theta is going up here. Does everybody understand that? Do you have that? So it's angle. I'm going to rip this off for a second so people can see this a lot better. That better for the people in the back? And this was 3,000. Am I correct? It was at a constant, 3,000 feet. So since we talk about angle, we got to bring in a set of functions called what kind of functions? Trig functions, correct? So we're talking about these two sides. This side and this side. Now notice, I'm talking about related rates. How is this angle and these two sides related using which trig function relates this angle and these two sides? Tangent. So tell me exactly what to write. Tangent of what?
Theta equals S
over what?
3,000.
Perfect. Okay? I'm going to change it slightly. And this is just my personal preference. I like 1 over 3,000. I like writing it as a coefficient. Okay? You don't have to if you feel okay with that. Okay? That's my relatable equation. It's what connects those three things, the angle and the two sides. If the sides were over here, if it was these two, I'd use cosine, correct? If it was these two, I would use sine. Does that make sense? So now I'm going to take the derivative of this. What's the derivative of tangent? Nope. Secant squared. Remember, it's one of those you got to times d theta dt. Well, the rate that the angle of elevation is changing is d theta dt, and that's what I'm trying to find. Is equal to 1 over 3,000 times, what's the derivative of s? ds dt. Everybody with me on that? Allie, you got a question? Okay. You sure?
Yep.
Okay. Nothing I could do a better job of? Not at the moment. Okay. So I know this right here. So I get 800 over 3,000. I don't know if you guys ever did that. I always did that as a kid because it just made me feel good. So I get 4 over 15. I just like smaller numbers. D theta dt equals, I gotta change the pens, times 1 over secant squared theta, right? Well, 1 over secant squared theta is what? Yeah. Right? So let's go back to my beautiful triangle. Let me do some math. This was 800, this was 400 here, correct? Right? This is 3,000 here, correct? Right? So that means this is the tangent of theta is equal to 400 over 3,000, right? Would you agree with that? Bam, Bam. So the tangent of theta is equal to 2 over 15. Would you agree with that? Does that look okay? So if I go back to my triangle, here's theta, here's 2, here's 15, here's the square root of 221. Oh, that's wrong. Not 221, 229. How did I get 229? What? Yeah, tell me what I did. 15 squared is, and 2 squared is, and 225 plus 4 is 229. I accidentally subtracted. Okay, I knew you caught me, so I wasn't going to bring it up. But since you did, I'll tell you the truth. Okay. So that means the cosine of theta is equal to 15 over the square root of 229, right? Did I just lose you? Not you? Did I lose anybody by doing that?
Yeah.
That? Okay, are you okay now? You see where I got 229? Okay. You see where I get cosine? So now I'm going to do this. You know what cosine theta squared is? 225 over 229. 15 times 15 is 225. How do I know that? I swim. And so I do math so I don't drown. Because that's what I do when I'm afraid. And 15 times 15 is really 15 times 15. Well, 15 is 3 times 5, correct? So it's really 9 times 25, isn't it? And if you have 9 quarters, you have $2.25 in your pocket. Which means if you're going through the airport, they're going to ding you and do a body search. So take that change out of your pocket. Okay, keep it in your purse. But if you don't have a purse, you got to have it in a pocket. Okay, that's just what happens. Alrighty. So this is going to equal to 4 over 15 times 225 over 229. Correct? Right? Right? Now I know you could have done this all on a calculator, but using your head is so much more fun. What? Yeah, you know how I'm going to do it? 15 goes into 225. You know how I know that? Because 225 is a perfect square of 15. So when I do this, there's going to be a 15 here. And guess what 4 times 15 is? So my answer is 60 over 229. Now you could have done this on a calculator, but I'm more interested in what's the units? Like this? Is it? Can you see it now? You want to go up? How do you want it? So what's my units? No, not degrees. You'll get it wrong. What? It's not feet, it's an angle measurement. And we don't talk about degrees in this class. Rads per second. Or radians per second. I like rads. Cameron, you've got a furrowed brow. I just like saying the word furrowed.
Any points or anything, why would we try and find
Because in right here, we had this, correct? Right? And so I took the derivative, I get secant squared. So I got to know what that value is. Well, that's the same when I bring it to the other side, it's cosine squared, okay? So I got to know what cosine is. So I came back to this triangle and said, okay, if I know these two sides, can I figure out what cosine is? Well, holy buckets, 403,000, those are big numbers, aren't they? So I made them smaller, 2 and 15. Now, you could have used your calculator to come up with that number, right? And you could have taken 3,000 and divided by that number to know what cosine is and squared it using your calculator, and there would have been nothing wrong with it. I didn't want to use my calculator and was wondering through this, is it possible to do it without your calculator? And it is if you make these numbers simpler. Now you have to know a little math. You have to know that 15 squared is 225. You have to know that 225 plus 4 is 229. Okay? But up to this point, you could have used your calculator to figure out what cosine theta was. Okay. Ellie, okay? All right, I'm going to stop.